is Poornima. Did I get that right? Poornima. Unnikrishnan. Poornima. I'm going to risk it again. Unnikrishnan, who is also in the Department of Yeah. And here at the University of Waterloo, and she's going to tell us about flood coincidence analysis.
Thank you. Good afternoon, everyone. So I'm Poornima Unnikrishnan. I'm a postdoctoral fellow at the Department of Systems Design Engineering, University of Waterloo. I'm pleased to present some of the outputs from our research here in University of Waterloo with Professor Poornima, who is present right here, and Professor Nirupama Agrawal and Dr. Kare. It's on flood coincidence analysis using Copula. So, Professor Nashri's talk gave a detailed explanation of floods and flood impacts on the public health and mental health and everything. So, as you all know, due to the current climate change scenario, the intensity and frequency of flood events are expected to increase. So there is an importance, or there is a need to understand the flood dynamics of every region in a more holistic manner. So the figures or the pictures here are the flood that has been occurred in Cambridge area in Ontario in the past, which is the study area for this talk. And so the topic of today's discussion is about joint flood risk. So why is it important, or what is it? So we, when we say flood analysis, or to determine the flood risk impacts, usually what we do is do a univariate analysis. That is, traditional way of doing is understanding only that one flood characteristic or one flood, the one river flow events, and then analyze it. But it's also important that to understand the flood dynamics, or is there any chance that there could be a simultaneous occurrence of floods in different rivers in the same region. So that can cause serious impacts. So that is the aim of this study, to find out the chance of simultaneous flooding of rivers, which can cause disastrous impacts of urban settlements. And also here, Copula functions are used to find out this joint flood risk. And these functions can be used in multivariate hydrological risk assessments. So some questions in this in this talk, which we are trying to address, are: how does the peak river flow in a catchment correlate? And also, how can we use Copula in identifying the interdependence of peak river flows and estimate the joint return period? So this is the catchment, Grand River catchment, which is the largest rivershed catchment in southern Ontario. And we are studying the Cambridge area, where two rivers, Grand River and Spade River, coincide in the city of Cambridge. So here it's the Cambridge is located at the confluence of Grand and Spade River, and it is they meet at a highly urban settlement area. So what if both the rivers exceeds a particular flow value? So then this urban settlement can be flooded in a disastrous way. So what is the chance of that, or what is the probability of that? And we chose this region because the first and foremost reason is two major rivers are meeting at the city of Cambridge, which is an urban settlement. And also there is a frequent occurrence of flood in the Cambridge area, and there is a long history of large flood events that have occurred in Cambridge. So Copula is, so finding out joint probability of different random variables is not an easy task if the random variables are dependent to each other, and also if the marginal distributions are different. So here we can use Copula, because as per the Star's theorem, Copula is any multivariate joint distribution can be described in terms of a Copula, even if the marginal distributions of the random variables are different. We can use a Copula to find the joint distribution function of those two random variables. So that's the advantage of Copula, and that advantage is used here to analyze the river flow events in two rivers, the Grand River and Speed River that meet at Cambridge. So different types of Copula are available. Some are listed here, and mostly Copula are being used mostly in finance, where extreme events are studied based on this Copula, and based on the multivariate distribution, or based on the multivariate data we have to select appropriate Copula that meets or satisfies the need of the multivariate distribution. So the Copula in flood consensus analysis, it is used to find out the joint probability of simultaneous flood events. We have considered two rivers, Speed and Grand River, that meet at Cambridge. The extreme river flow, annual extreme river flow events in both Grand and Speed River are analyzed. And a Copula function is fitted to the data so that the joint probability of events in the two rivers are estimated. So these are the time series of Grand River flow and Speed River flow over from 1951 to 2021. The extreme events, annual extreme events in Grand and Speed River flow. And by analyzing these two flood events, extreme events, it is we have to find out the marginal distribution of both these, the Speed and Grand River. The different marginal distributions were tried, and the best fit marginal distribution was found to be normal distribution and gamma distribution for Grand and Speed River. So the marginal distributions are different for both the river flows, and also they are dependent to each other. There is a correlation coefficient of 0.7 between these two extreme flow events. So they are dependent also, and the marginal distributions are different. So here comes the use of Copula. So different Copulas were tried, and the best fit Copula was found to be the Joe-Clayton Copula. And this figure shows the observed river flow extremes of Speed River and Grand River, and the simulated river flow extremes of Speed and Grand River based on the Copula fitted. It can be seen that based on the Copula, the river flow extremes were reliably simulated using the Copula. So usually in flood analysis, the major term that we use is return period. So I know most of you might be aware of this term, but it is the average time interval between occurrences of event which greater than a value, and is described by this equation. It is based on the exceedance probability of an event, and it is the average in the time interval between the occurrence of exceedance of that event. So this is return. This equation is for a univariate return period, but here we are concerned about the joint return period by using the Copula. So for joint return period, there can be two cases. One is, what is the time interval between both the river flows exceeds the values, and another one is, what is the time interval between either of the Grand River or Speed River exceeds the maximum flow value. So those both should be considered, and the equations for both based on the Copula and the marginal distribution functions is given here. C is the Copula that is being fitted between the Grand and River Speed River flow extremes, and U and V are the marginal distributions, and this is the T return period for and or case. So based on this, the bivariate and univariate return periods for Speed and Grand River flows extremes is given here. The last two columns are the return periods based on the traditional univariate concept without considering the dependence between the Grand River flow and Speed River flow. And T and TO are the joint return periods calculated using Copula by considering the dependence between the extreme values. And it can be seen that for higher flow conditions, considering the joint return periods or considering the interdependence between extreme values are important to get understand more about the flood dynamics. For example, The last event here, which is the 90 and 700 flow in Speed Flow and in Speed River and Grand River, is a 12 and 15-year event when considered as univariate analysis. That means we are not considering the interdependence between the flows, but it is a 10-year event if we are considering the interdependence between the Speed or Grand River. So it becomes a 10-year event if we are considering the interdependence. And also if we are considering the 6-year return, 6-year event, which is this 6-year event here, it translates to a 9-year of simultaneous occurrence of the events. That means there is a chance that once in 9 years, both the rivers can exceed this flow. So this also needs to be considered. The impact on the urbanization or the impact on the people will not be the same when both the rivers exceeds the flow and when either of the river exceeds the flow. These factors also need to be considered. And by concluding my remarks, this highlights the benefits of considering dependencies between extreme river flows at the two rivers. And univariate analysis focuses on modeling marginal distribution without considering the interdependence between different variables. And on the other hand, bivariate analysis using Copula, it considers the interdependence between different extreme events, and it gives the joint probability of occurrence of different events. And this leads to a more comprehensive understanding of the relationship between two river extremes, and it can inform the risk management and decision making in a way that univariate analysis cannot. Thank you.
Thank you very much. So I think I will have our speakers can just sit where they are, and we can direct our questions to them. And we have